I am staggered by multiple universes. More than one universe? Isn't the universe everything? According to current cosmology, we live in an immense multiverse, a limitless ensemble of disconnected regions of space-time, each alone a universe, each alone exponentially larger than all we see with our largest telescopes, each alone with different laws of nature, and altogether unimaginably vast. I am dizzy, but determined to dig. What would multiple universes mean? I'm Robert Lawrence Kuhn, and Closer to Truth is my journey to find out. I begin at MIT with the scientific director of the Foundational Questions Institute, Max Tegmark. FQ of X explores beyond the frontiers of physics and cosmology. Max tells me that for every 10 serious papers he writes, he allows himself one wild speculation. If we're talking about these multiple universes, how do we generate them? Are they just some wild philosophical idea, or are there real physical mechanisms by which we can hypothesize that they actually can work?
Our universe is just the finite region of space, so it's not that crazy sounding to imagine that you would have more. If you really don't like a lot of space because you suffer from agoraphobia, then there are mathematical models where space is like a donut, you go very far and you come back from the other side. But that's somewhat unsatisfactory, because then you suddenly have to explain, well, why is this donut exactly the size of what we can see right now? You know, when in fact in the past what we could see was much smaller, and in the future what we can see is bigger. You've just bought yourself another unanswered question in your attempt to get rid of all this space. So the simplest space is just one that goes on forever, and that's also what our simplest theory just produces for you.
And in that theory you will have maybe an infinite number of different universes, sort of each one squeezing out from one another in some way?
That's right. It's sort of self-similar, right? If one piece of space can generate more, then those are going to go on and do their own thing. And much like bacteria, just keep doubling, doubling, doubling.
Space, like bacteria, doubling without end? Nice metaphor, Max. But is this poetry or reality? I push for more, so Max invites me to Iceland, where FQ of X members meet to discuss the big questions. I catch Max in the Blue Lagoon hot springs.
So Max, you really believe this stuff of multiple universes? I mean, it sounds good and it's sort of fun, but I mean, do you really believe it's real?
I really believe it is real. Yeah, I'm amazed by the fact that not only do we have good evidence for some kind of parallel universes existing, but there are many different kinds of parallel universes. And it's just shockingly difficult to write down a theory that describes everything we see in the universe and nothing more. When we look at the physics of quantum particles, we know that light is made of quantum particles called photons, for instance. You can see both light getting reflected here off the water surface and also going through the water surface, as you can see in my hand, which means that when you do the math, these photons end up in two places at the same time. And you can do the same kind of experiments to show that the particles that you and I are made out of, like electrons, protons, and neutrons, can be in two places at once, which means that we can be in two places at once. And the amazing thing is, if you're in two places at once, both of those yous will in fact be unaware of the other you and think that for all practical purpose, that's
the
it.
only one.
Yeah, so that kind of parallel universe is even right here.
And those keep branching.
Yeah, and that turns out to be the simplest version of quantum theory, has the parallel universes. I think ultimately there might even be an even more extreme kind of parallel universe where if we can ever figure out a set of equations you can put on a t-shirt that describes everything about this universe, there's probably a different universe for each kind of t-shirt as well.
If we look at these different kinds of ways of generating parallel universes, the common factor that they seem to have is that in each kind of theory, that is a simple way of describing that theory.
Exactly. We have a very beautiful theory, for instance, for why the universe is so big, called inflation. Where you can have a small amount of space, which actually stretches out. Space gets bigger, you produce more volume. Problem is, it never stops. So the simplest inflation makes an infinite space, which means
try to
you
stop
have all
it,
these
it's more
parallel
complicated.
universes. Exactly. So the parallel universe theories tend to always be simpler and more elegant, therefore, from the point of view of us physicists, than
But now you're
a theory which
describing,
just has us.
You're describing, again, 3 different kinds of parallel universes.
I would say even 4 different kinds, because if one looks at modern string theory, it turns out that there's more than one solution to it. And the best theory we have for what made space so big and got it started here ends up making different parts of space where we have these other solutions.
Okay. How then do you know which of these exist, and do they all exist? And if they all exist, do they fight each other, or do they nest with each other and make even a higher order of infinities?
Yeah, I would say some of them actually nest with each other, in that the theory of inflation that stretches out and makes space so big also ends up using this quantum mechanics as a mechanism to decide whether to put the planet here and that planet there, or put them somewhere else.
Max poses at least 4 radically different kinds of multiple universes. Cosmic inflation of space, quantum branching, string theory, and, wildly, innumerable sets of mathematical equations. I stand stunned by the reach of reality. I seek meaning, the meaning of it all, but meaning seems swallowed by interminable spaces. And if there's no meaning, I mustn't fake it. I hear that another cosmologist, also in Iceland, is willing to confront meaning. Anthony Aguirre is FQ of X's Associate Scientific Director, and he specializes in the multiverse. Anthony, if multiple universes really exist, what would they mean?
Well, it would tell us what the nature of reality is in the most fundamental way. It's a tremendous widening of your intellectual horizons. And it's not just bigger, but it's so much more diverse. And that's the more exciting thing, I think, about the multiverse. And it changes the way you think about almost every question in cosmology and in fundamental physics. If you were just imagining multiverses and thinking, well, let's assume that all kinds of other different universes exist with other properties, you actually wouldn't come up with something that's quite as neat as what nature seems to have come up with through this mechanism that's called eternal inflation and through this idea that's called the string theory landscape. I find one of the most exciting things to be this confrontation with, almost with paradox, or with the thing that you just can't quite believe. So there's this question that's been lying around for a long time. Why does the universe seem so hospitable to life? It seems like if you change lots of the fundamental parameters, the strength of the electric interaction, the strength of gravity, just a little bit, life as we know it can't happen, right? So how did we get so lucky? It could have just been the universe rolled the dice and we landed 12 sixes in a row and here we are.
More like a million sixes in a row.
Could be. That seems hard to swallow, right? So you look for all other explanations. It could be that life forms naturally in any sort of universe that there might be. That would be pretty exciting, right? That would mean that, at least in theory, there are wildly different life forms, completely different from us, based on completely different physics, that nonetheless exist and can contemplate the world and think how great it is. And it could be that there was some element of design. There could be some supernatural agent that created the universe, or people travel back in time to create the universe, or create universes in the lab and so on, but designed so that they were hospitable. That's another option. Or it could be that there's this multiverse and that it's hugely diverse and we just live in the places where we can live. And what I love about this question is that it's hard to think of too many more really categorically different things that you can ways that you can look at it. I love contemplating these sorts of things. When you really take something that you can't quite believe and then understand, I have to believe it, but I can't believe it, but I have to believe it. And this is another interesting question, where the either answer is hard to believe. Either the universe started and then there was nothing and then there was suddenly something, or there wasn't nothing, that's even more confusing, or it didn't start, right? So what does that mean if it goes eternally back into the past? And again, all the answers are interesting.
Multiple universes change just about everything we thought we knew. And every ultimate explanation is literally unbelievable. How are multiple universes generated? The accepted mechanism is cosmic inflation. If I search for meaning in the vast multiverse, I must understand inflation. And that means I must visit Alan Guth at MIT. I'm in awe of Alan. He's the originator of cosmic inflation, the key theory that made multiple universes serious science.
I think one of the lessons that one learns early on when one starts to think about cosmology is that the universe is unbelievably large, and by any comparison, we are therefore unbelievably small. And if this theory called inflation is right, there are probably unbelievable number of pocket universes as large as what we observe, or vastly larger. In fact, the number is even very likely infinite. That certainly means that any importance that we have has to be an importance that we give to our own lives. We can't look to the cosmos to find the importance of human civilization.
What has always impressed me and almost made me quiver is the fact that all of this knowledge has been achieved in what, 5,000 years of recorded history, and how much science? I mean, really, it's only 400 years of science, and even in the last century, we've advanced so much. Less than an eye blink in the totality of universal time.
Yeah, no, I completely agree. The other side of the story that I want to get to is that I think cosmology is, I think, a tremendous exhilaration from the point of view of appreciating the power of human thought. And I think it's mind-boggling how successful this enterprise has been. When I first proposed inflation back in 1980, we discovered, I guess, in 1982 that inflation made definite predictions for the non-uniformities that we thought should be seen in the cosmic background radiation. At the time we were doing these calculations, I didn't think there was any chance in the world that these very minute variations in the intensity of the cosmic background radiation would ever be seen. To give you an idea of how hard this is, the intensity of radiation is proportional to the fourth power of the temperature. The temperature of the cosmic background radiation is 3 degrees Kelvin. The walls of this room are 300 degrees Kelvin. So it's 100 times as hot in this room as the temperature of the cosmic background radiation. That means the intensity of the radiation coming off of that black wall over there is 100 million times more than the intensity of the radiation in the cosmic background radiation. Yet the astronomers can detect this cosmic background radiation, and they can even detect variations of this cosmic background radiation, which are the order of 1 part in 100,000 of the intensity of the radiation.
Wow.
And they can do that accurately. It's unbelievable. I find it completely unbelievable. It's really a tour de force of modern science and technology. It's fantastic. And then to see that the measurements they make actually agree with the predictions of these theories, I find just astounding.
The work that you do on inflation carries you back not to the first second of the universe, 13.7 billion years ago, but you deal in the first incredible small part of a second, 10 to the minus 37th or minus 35th. I mean, time frames that are just unbelievable.
That's right.
And you do
That's
that
right.
so casually. You get up in the morning.
Well, when I started, it seemed absolutely absurd. The origin of most of these absurd numbers, by the way, comes from the grand unified theories of particle physics on which this cosmology is based.
And what's equally remarkable is that the way this works is that you have to take two different kinds of observations and theories. One are observational astronomers looking at the most massive things we can imagine in our perception, the size of the entire universe, what is it, 10 to the 28th centimeter or something. And then you're taking particle physics, theoretical physics, experimental, dealing with the very smallest possible thing in 10 to the minus, who knows, 14th, 15th size in that. And you're only able to explain the former, the great size of the universe, by understanding the latter, the quantum physics and the structure of this. I mean, that unity is astounding.
Yeah, the amazing thing is that studying the very small over here connects hugely to the vast expanses that are probed by astronomy.
To me, Alan's insight is one of humanity's greatest achievements ever. I'm stupefied by what one ordinary human being has discovered. But how to get from cosmic inflation to multiple universes? The long road winds through Russia and Stanford, where I meet Andrei Linde, together with his physicist wife Renata, an expert in string theory. Andrei devised eternal, chaotic inflation, generating myriads of universes without number or end. And he, like I, wonders what it's all about. So Andrei, did you learn string theory a little bit from Renata?
Well, I think that she learned much more cosmology from me than I have learned string theory from her. Because string theory requires a lot of mathematical preparation and knowledge. Cosmology, it's so easy.
Okay, we have these two dominant theories in the world, multi-universes in cosmology and string theory with all the different vacua in string theory. If both are real, they have to work together. Renata, how would that begin to happen?
I agree with you. And so what actually was the status of this working together, it didn't. But under pressure of these facts that the universe we observe shows this acceleration, and there was this very strange feature that the cosmological constant, apart from being non-zero, which people were hoping, is also an extremely small number. All of this was very unusual, and also it was fascinating. So the cosmological constant, if we compare it with the natural value of Planck mass to the power 4, has a number in front of it, which is 10 to the minus 120. So you take 1, and then you have 120 zeros, and then you take 1 and divide on this huge number. Then you have this extremely small number. And this never happened in physics. And to explain this number remains a fantastic challenge. And this is where the idea of a landscape of string vacua.
Landscape meaning many, many different possibilities.
So how many? One of the reasonable counting is to say that it is at least 10 to the 500.
So a 1 with 500 zeros is the number of different string
It's
theory
the number in which people
vacua.
agree that they give reasonable amount of worlds around us. In the end, after we can construct at least one vacua which looks like the universe which we see now, then we have plenty. Wow. We have huge number of them.
Andrei, so then how does it work for all the different vacua of string theory to map on to the different universes in the multiverse and giving each one a different characteristic?
Well, you know, the properties of elementary particle physics they depend on the way how this internal space looks. So, in different parts of our universe, in one part you may have this type of compactification, in another part you may have another.
People were hoping to find one unique solution of a problem, and this doesn't look likely now, because the solution is obviously not unique. We have too many, or at least as many as we can construct. And so the way to ask the question now is not why, for example, the cosmological constant which we see is the way it is, It is rather why we live in a place which has chosen this particular cosmological constant which we observe, because there are so many, and theory allows them.
Well, this is what you're referring to as the so-called anthropic principle, and you've both worked on this, and it's very controversial and misappropriated by some people. Other people are very critical of it in your field, but the question everybody asks is, it seems like philosophy that it's impossible to verify, and there's no experimental evidence.
Well, I would disagree with that. You know, we have some experimental facts. The fact is, we have electron and we know its mass. And we know that this mass is very unusually small. But we know that if this mass would be 2 times larger or 2 times smaller, we would be dead. Our life is correlated with this particular value of the electron mass. So then, why is it so that we have all of these unexplained numbers, and there is still a very strong correlation between them and our life? And the only theory which, as of now, explains this experimental, I'm emphasizing, fact, is the multiverse theory, because it allows you to try. You can live here, you can live here, you can live here. If you would have just one universe, it would be your responsibility to prove that only this mass is possible and only this vacuum energy is possible. But right now we have a possibility to explain the correlation between these masses and your life.
To Andrei, the meaning of multiple universes is that they explain the incredible fine-tuning of our single universe. Yet innumerable universes seem a hefty price to pay for explaining the one universe in which we find ourselves. Not every cosmologist is a convert. I hear Paul Davies equates the multiverse theory with the God theory, which for him is not a compliment. He says both theories account for this universe by going outside of it. So he rejects them both. No multiverse, no God. Okay, Paul, then what?
The simplest thing is to try to explain the universe we see from entirely within it without appealing to hypothetical entities that exist outside of it. And the problem about the multiverse is not that such a thing is unreasonable scientifically. It's not. It's very reasonable. It's that how on earth are we going to know about these other universes? They're not directly observable because in the fashionable view based on eternal inflation, these other universes are being conveyed apart faster than they're expanding. And so even in principle, you can't see across the gulf between them. And so I think the main objection, it's just a philosophical, not a scientific objection, is that what you're doing is trying to explain the universe we see by appealing to, in this case, an infinite number of universes that we don't see, appealing to something outside of the universe. And that is no better than traditional theology, which simply says that there is an unexplained God outside of the universe that is necessary to explain what we see within the universe. I would like to try to find an explanation for the universe from entirely within it, without appealing to anything external. And as a matter of fact, I believe that if somebody did a proper mathematical analysis, they would find that the complexity of the explanation of the multiverse, an infinite number of universes we don't see, is the same as the complexity of the explanation of traditional theology, an infinitely complex God outside the universe that we don't see. They're really the same thing in different language. And so my point of view now is a plague on both your houses. We need to try to find the explanation for the universe from within it, from what we see, and not multiply these unseen entities. I really don't believe that any universe you like is out there somewhere in this ensemble. I think that idea is just ridiculous and it explains nothing. After all, the principle of trying to explain the universe we see by invoking all possible universes is not an explanation, because by invoking everything, you really explain nothing.
If multiple universes are real, an infinite number of universes, everything does change.
History of
Whatever you believe, no God, God, nothing's the same. If only the material world exists, the material world is inconceivably larger. If an infinite God exists, God's infinity is amplified by astounding new meaning. If multiple universes are real, for all future history, Alan Guth and Andrei Linde will be lauded as discoverers. Yet Alan and Andrei are normal people. Normal people on an ordinary planet. Normal people envisioning multiple universes. Normal people seeing shadows of infinity. I can't imagine anything closer to truth.
For complete interviews and for further information, please visit closertotruth.com.